Hi there, this is video 721. We are doing the quadratic formula again, and we are using it to find the x-intercepts of a graph. Okay, it's useful when, one, you just literally don't want to graph it. Two, if your x-intercepts are not exactly on the line, so they're not at like -1 or -2, it's somewhere in between and you want an exact answer. Also when they're just really big, and to graph it would be kind of crazy. So lots of reasons to do it, good reason to know how to do it. And the last video, 720, kind of did some simpler ones. These ones are a little more interesting, I think. But the process is still exactly the same all the time. So first thing I'm going to do, A is equal to 9, B is equal to -12, and C is equal to 4. So x is equal to minus b plus or minus square root b squared minus 4ac all over 2a. I know you didn't need to do that. So x is equal to, need to be careful, minus 12. Again, the minus from there and the minus from there, plus or minus square root minus 12 squared minus 4 times a, which is 9, times c, which is 4. Extend that line. All over 2 times 9. So x is equal to 12 plus or minus square root of 144 minus, I don't know, 4 times 9 times 4. Ooh, okay. 144 over 18. X is equal to 12 plus or minus square root of 0 over 18. Now, that's okay. If you check your calculator, you can do the square root of 0, which happens to be 0. This is one of those things where you get, you know what? I'm not going to tell you what you get. Let's just finish it off. So x is equal to 12 plus 0 over 18, right? We're doing our split. And that's going to be 12 over 18. 12 divided by 18 would be 0.67, so 0.7. Okay, again, that's rounded. Or x is equal to 12 minus 0 over 18, which means 12 over 18, which means 0.7. So this is like what we did when we had the vertex ones, and we ended up with 0 on one side and just the x minus whatever on the other side. So essentially we're getting two roots, but they're exactly the same. So when you graph this, it'll just like look like this touches the x-axis only once. So don't be worried if you get a 0 in there. Actually touches. Doesn't actually cross, it touches it. Okay, so that's one of your options. I should have said this earlier. Probably just turn off the video now and do these last two questions and see how they turn out. Right, so A is equal, careful on this one, -1. B is equal to 8. And C is equal to 0, right? It's not there, so we could put plus 0 there. So and you're thinking, why are you writing it? It's sitting over there. Well, you know what? If you write it out enough times over the years, you will memorize it, and that's a cool thing. So -8 plus or minus square root of b squared 8 squared minus 4 times A was minus 1, times C, which was 0, over 2 times minus 1. So x is going to be minus 8 plus or minus the square root of 64. And this is all going to go to 0 over negative 2. So x equals minus 8 plus or minus root of 64 over minus 2. X is going to be minus 8 plus or minus, oops, not 64 anymore. We're going to take square root of that, which is 8. You know that. Over minus 2. And we'll do our split. So minus 8 plus 8 over minus 2. Or x is equal to minus 8 minus 8 over minus 2. Oh goodness, what's that? Fix that up. Minus 2. So x is going to be 0 over minus 2, which is going to be 0. And x is going to be minus 16 over 2 minus 2. And that's going to be 8. And you should have yelled at me on this one. 0.7 and 0. We're looking for x-intercepts. So they should be written as points. And here you're going to get 0 and 0. And 8 and 0. Okay, last one. A is equal to minus 3. So you can see. B is equal to 5. C is equal to minus 4. X is equal to minus B. Goodness. Don't know why I'm doing that today. Minus 5 plus or minus the square root of 5 squared minus 4 times minus 3 times minus 4 over 2 times minus 3. X is equal to minus 5 plus or minus 25. Now we've got a minus and a minus and a minus. That's going to make me a minus. Pretty sure 4 times 3 times 4 should be 48. Yes. Minus 5 plus or minus. Right. Yeah. 25 minus 40. Oopsies. Too much. 25 minus 48. Negative 23. Minus 6. Okay. I knew somewhere in this example there had to be one of these. If you remember when we did the vertex, there was a deal that you can't take the square root of a negative number. So this one, you can stop right now and all you have to say is, has no x-intercepts. Okay, now one last thing. I caught myself, I made a mistake on the last video, so I want you to do a double check. So this is negative 12 here. When I do my work here, that should be a plus 12. That was 8, so negative 8. And this one was a 5, and that's a negative. All right, so this one is a really good page because it basically gives us all our options. You can have a 0, which means you have a 1 root. You don't have to write it twice. And truthfully, you don't even have to do this part twice because 12 plus 0 and 12 minus 0, of course, it's going to be exactly the same. But I wanted to prove a point. Okay, you can have one like this where it works out and you have 2 roots. And you can have one like this where you get negative under the root sign And at that point, you can say, there are no x-intercepts. If you want to double check your work, one of the easiest things to do is after you've done all this, just simply type these into decimals and you can see what the roots are supposed to be. Sorry, not the roots, where the x-intercepts are, which are also the roots to the equation. And you can check it out. The only other crazy thing you might get is that was a really nice number of 64 because it has a perfect square root. But say it was a square root of like 65. Can you just use your calculator? Okay, that example. So in that case, I guess I would use, yeah, you can see 8.06. I would use 8.1. Always round to one decimal place when you're dealing with graphs because you can't really plot a point to 2 decimal points. That makes sense? All right, excellent. That is a quadratic formula. Very, very powerful tool. Great.